Hey everybody, this is Larry. This is me doing an extra problem for today. I feel like I haven't done this in a while, but I do have premium for I don't know how much longer. So we'll see. I'm going to try to do a random premium that I haven't done yet. Yeah. And then we'll see how far I get. Yeah, let's do it. Wow, and off the bat, we're doing a hard one. So let's see. Today's premium problem is 1956. Minimum time for K virus variants to spread. Hopefully this isn't too impossible because there seems to be a few of those. Okay, there are n unique virus variants in an infinite 2D grid. You give an XY, okay, XY on day 0. Right. Notice that it's possible for multiple virus variants to originate at the same point. Each day, you could look at that all 4. Okay. And then return the minimum integer number of days for any point to contain at least k of the unique variants. Oh, okay. That sounds hard. On day 3, okay. So, I think the short answer is going to be, I'm not going to lie. I really thought it was going to be binary search, and I look at the constraints. I'm having second thoughts. Well, is this really hard? Not gonna. Yeah, I thought there's gonna be some tricky binary search, and then we have to figure out how to. Yeah, I mean, I don't think it's even that hard with a binary search. That's why I'm a little bit confused, to be honest. But maybe I'm missing some new ones because you can get the. Yeah, maybe it's still binary search. Maybe I'm a little bit confused. But at most, this is going to be at most 200 days. And then if you do a binary search, it's just 100,000, or 100 times 100, which is 10,000. And 10,000, you can loop that easily. 10,000 possible points because it's not going to be outside the min or the max of those things, even though they say it's infinity. Infinity to the grid as long as it's within 10. I mean, but that's all your bounding box. So, if you do your min and your max, then that should be okay. And you have at most 50 points. I don't know if I'm confused the n for 50 and 100. But I could see that you could, if you're sloppy, then, yeah, I don't get it. Maybe I'm just a little bit like wondering if I'm missing wondering if I'm missing something, to be honest. But here you can actually, because it feels a little bit too easy for me, or not even. Hopefully, I'm not coming off as sounding like I'm bragging. But sometimes I guess I just expected, like reading the problem, there is a harder problem in here, and then they just kind of chose like a easier one, if you will. So I don't know. But anyway, all right, let's get to it then. And yeah, let's get to it. And then we'll just do a bounding box because we're lazy. How do I write this? Min x, max x. The min. So for xy in points, x, right? So then we can do this. We can do this. We can do this. Yeah. Just a lot of copy and pasting for now. Hopefully I don't make a mistake because that's what happened last time or the other day. Okay, right. All right. So then now. That's so far. Then I'm like a little bit confused, to be frank. Let's just do it. I mean, because in theory, you should be, like, if you do a buffer search, it's fine as well. Maybe not. Maybe that's just a weird way of phrasing it. But yeah. What am I trying to get again? Oh, K is the thing. Okay. So how do I write this? So for this point, so basically for x in range of min x to max x 1, right? And then now, if this point is a possible answer, how long does it take? Well, yeah, you just kind of do all of them, and then it's like a heap thing, right? Just top k, right? No, top k. I'm gonna change this to big K because I feel like I sometimes reuse variable names sillily. Yeah, I mean I think that's it, right? And there's only 50 elements. I feel like using a heap may even be too much an overkill. But I'm just gonna use sorting just because I'm a little bit lazy. But I mean we can optimize this. This is easy to optimize. So yeah. Best is equal to, I just say n times, I don't know, 3. It doesn't really matter. N times 3 should be infinity because that's just you can do a proof to show that that should be sufficient for any number. But yeah, before maybe I'll write this as cx for cy for current x current y. So then I can write this, and then distance is equal to is we append this is just Manhattan distance, and then now we sort. I've been using too many languages there. Okay, so that means that for k, is it k minus 1 is the distance of the, yeah, I think k minus 1 should be good. So yeah, so best is equal to min best d of k minus 1, and then we just return best, and that's pretty much it. I mean, maybe it's too slow, maybe I get confused. Okay, fine. I should make it a habit anyway. This is probably a healthier habit. If it times out, it times out, but though it shouldn't be. And we can even, I'm too lazy to write it out. I guess the points are not distinct necessarily, but we can actually just do something like points is equal to, I mean, we don't only care about running time, so we can actually do something like, I don't know, xx for x in range of like 100 or something, right? That should be fine. I guess it has to be between 1 and 100 and not 0 and 99. That's fine. So what we're looking for is just the running time. It takes 728 seconds or milliseconds to run 4 cases, so we should be okay. What do we return anyway? Expected 3. I returned 1. Yeah, I guess that sounds about right. Wait, am I off by 1? I have to make sure. No, I guess to see if I'm off by 1, I guess I can just run the actual thing. So we look good here. Let's give it a submit. Maybe too slow, but we'll see. Oh, did I misunderstand this problem? Maybe I misunderstood this problem. Or did I have a typo? Both are possible. Why? This isn't. The thing is that this didn't even feel like it's off by 1. If it's off by so much, but yeah, it's gonna print out a lot of stuff, but CXOID. k is 2 minus 1, so sure. Okay, and I put down 6. Why do I have 6? If d of k minus 1 is equal to 6, maybe? Where did I get 6 from? Oh, I put n. Okay, it's from that. Okay, that's just me being dumb. I actually. I didn't mean n as an n. This is so dumb. Okay. I mean n as in like the size of the grid. For some reason, I think in my head, I think of this as an n by n grid. So when I wrote n times 3, that's what that means. Okay, fine. Let's just do infinity. I'm too lazy to think. That was me trying to be clever and instead got fooled by myself. All right. I mean, it's a little bit slower than whatever. You probably could optimize this by changing this to a heap. In Python, it's not always a given, to be honest. That's why you have to do, because sorting is very optimized because it's a very common operation. If you use heap, you have to do, for loops in Pycode and just stuff like this, and that actually may be slower. I wouldn't be surprised if that's the case. Did have a silly mistake here. I think in my head when I write n because I think of this as a grid problem, and when I write n, I think of like the n by n in a grid or something like this. But then I got confused because that makes no sense otherwise. N times 3. Because what I was going to say is like, the grid times 3. So you could actually just write like 300 and it'll probably be fine. Infinity might as well be 300 or whatever. But that's what you get for trying to be a little bit too clever, I suppose. And then didn't think about it afterwards. I think I just confused the variable names for this particular one. Anyway, that's all I have for this one. Let me know what you think. Yeah, this is a little bit odd because the thing that we abuse, if you will, is the fact that the bounding box is not that big. So it's hard to kind of go over the complexity because there's just so many. Well, I mean, it's not that hard, but it's just like a very specific thing. Like if you want to say uppercase X is the range of X and Y is the range of Y's, then you have like X times Y times n log n for the sorting. This is O of n and this is n log n. So you have like X times Y times n log n, which for this problem is fast enough, but it's not that optimal. I think you can probably do some sort of binary search. I wonder, I mean, there probably is a lot more harder math with respect to like, in a way this is like median finding type thing, but only if you get the entire number, and if given k is not always a given. So I don't know that I can do a harder, I mean, I'm not saying that the harder version is not possible, it's just I don't know if I can do it. I mean, you can definitely think, I mean, because the way to think about that particular thing is just I want to say that it reminds me of the Renoy diagram in D0 or Manhattan distance, but I don't know that that's given, because in this particular case I don't think that necessarily there are a lot of quote unquote off the shelf standard-ish, as in textbook-ish, computational geometry that would kind of help you figure these out, but to be honest, I don't know that that, I mean, you can definitely do stuff in n square, or maybe not n square, but n square as a base, because so if you, and given that n is equal to 50, you can even do something like n squared log n squared. So I think maybe that's fine. Maybe there are ways around that to kind of like sort the the biplanes, something like this. I mean, I don't know. Maybe we're getting too hypothetical here, and I don't know. Like if I were to need to code this, I don't know if I know how to code this. But you can imagine like you could. I mean, and this is in D0 as well, versus like is it yeah, Manhattan distance versus like quote unquote regular planar distance. But I imagine there's an analog, and I could be very wrong in that particular problem. You could take the graph, and then you could take the dual of all the pair of points, which means almost like the lines that bisect the 2 points, and then it's just the intersection along those points, and then you have n square number of lines, and then to kind of find the I don't know. Yeah, there's some like sorting, and then maybe you can do some craziness. I don't know. I don't really have anything about here. Let's see if the solution does any better. Yeah, I guess you can binary. You could sweep line. That's the thing that maybe, but no binary search. Well, I mean, if you sort, I mean, this is basically my code, but I mean, technically true, not binary search. I originally think it was going to binary search, and then just kind of, yeah. I mean, I don't know if I would call it sweep line, but I think of it as like a frontier thing, of just, you know, like how many intersections. Because another way to think about it, right, is that you know, and the way that I think about it is, you know, with visualization, and the way that I initially visualized this would be with, you know, with regular, quote unquote, regular distance, which means, you know, x squared plus y squared is equal to d squared. And in that case, you can imagine just having circles, right? Then now you try to figure out any regions with k, you know, given these circles, you could, like, for a given, if you're binary searching, then you just find like you're binary searching on the radius, which is the same as the time in a different distance metric, and then now you're trying to find out for a particular graph whether there's a region with k or more thing, and then you binary search on that. Still pretty hard, to be honest. Like, not impossible, but pretty tricky. So I don't know. But yeah. Anyway, some things to think about if in case you're curious, in case you're thinking about this stuff. That's all I have for today. That's all I have for this problem. Let me know what you think. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye bye.